Great. I will ask Arushi now to introduce you, and maybe we can begin.
Great.
Hi, Arushi.
Hi. Hi, Dean Vince.
It's very good to see you as well.
You too. How are you?
I am well. We're in different times, but it's allowed many new things to actually happen, such as you had heard me speak with your mom. It's not every Saturday that I speak to Team India. So really happy to make the best of the situation that we have.
Thank you for taking the time to speak to us today. And a very warm welcome to all the participants as well. Today we have with us Dr. Vincent Wilczynski, the Deputy Dean of the Yale School of Engineering and Applied Sciences, and the James S. Tyler Director of the Yale Center of Engineering for Innovation and Design. Dr. Wilczynski serves as the co-chair of the first Executive Advisory Board and is a fellow of the American Society of Mechanical Engineers. He's also extremely passionate about FIRST and has been a part of FIRST programs for 26 years now. I actually had the fortune of meeting him 3 years ago as a Dean's List Award winner. And at the time, his speech inspired me to pursue computer science in college. And I hope all of you feel similarly inspired as he speaks today about FIRST as a launchpad for your future. Over to you, Dean Vince.
Well, it's wonderful. And it's just so special to have this chance this morning to be, this morning and this evening to be with everyone. And so I hope to do is to share a little bit of insight of what makes you special. And I think you're going to see that it's your ability to think in different ways and your ability to actually act in different ways. So if we walk through this, we're going to get a little bit of insider's intel, sort of the background here, looking at some people, and then see what that message actually means. As Anuchi had mentioned, I'm at Yale University. We have a Center for Engineering, Innovation, and Design. And so this is an area where you can come in and build rockets, or a lot of FIRST alums pop up in my talk. And so here is one of them leading a workshop in the Center for Engineering, Innovation, and Design. But what we're able to do is have a classroom that is directly connected to a studio workspace. And within that studio workspace, we can have workshops to cover engineering principles, areas for students to work, accessibility to hand tools, to modern manufacturing equipment, and even a wet lab for chemical biomedical applications. The heart of what we're doing is actually giving opportunities. And those are on the learn, make, share continuum, stretching from informal to actually formal. If we look a little bit at one of the components on the make side, in our open studio, it's a chance for students to come in and actually make things. That might be a rocket that you've seen, or around the holidays, a focus on apparel using the sewing machine. Workshops such as how to make chocolate at Valentine's Day, and then also providing support for any number of different clubs. One could say that this is a FIRST robot, but it's which is inspired by specifically a team building a robot for a Mars-based competition on Earth. Also outreaching to the greater world, whether it is, in this case, Cameroon, where a group of students have traveled to build water systems, or giving opportunities on the Yale campus to come in and to spend their summer with us to actually design products. This summer, JR and David were with us, and they partnered with the United Nations and the nation of Colombia to look at the concept of masking. And in this world of masking, integrating that actually with a face shield. So what they wanted to see for the government of Colombia is, if you have this face shield, all of this work is done in SolidWorks, which I know can mean a lot to the students here, including modeling the face shield, modeling the human face, and then the mechanism to test that under airflows. So if you take these designs, which came out of a competition in Colombia itself, just using SolidWorks flow simulation, you can see the path of air that is exhaled, and then you can see the path of air that is inhaled. What David and JR did is they were actually first-year students. So this is their first year out of high school, transitioning to the university, and actually then making an impact. Working with the New York Metropolitan Museum, Maria spent some time this summer taking care of the mummies. So the situation is that vibrations would cause the sarcophagus to actually begin to deteriorate. But what Maria did was look at that sarcophagus, and it sat on a pedestal. So if you study that pedestal, going from the real world here to SolidWorks again, you could apply fundamentals of engineering and look at the frequency of excitation, where this bounces around the most, and then design some article that could actually dampen that out. And that's actually what she did by creating these designs of a, basically it's a mass spring damper system. And over the summer, Maria is working in her home, but this is a real problem. So the solution was to actually get her a 3D printer. So this 3D printer costs $170 US, but its output is just tremendous. So even though Maria was remote, she could go ahead and design her solution, moving from the digital world actually to the real world, and then begin to test it to see how well it actually dampened out the vibrations of the sarcophagus. One last little insight into what we do at this design center, and this is very, very important and really key to our talk today, is that your experience as makers allows you to take this very sequential process of going through the curriculum from an introduction to a final project, but integrate it with all of your world experiences. In the class that I teach in the fall, we do that by providing the fundamentals, and then we find clients at the university, in this case, a center for the preservation of cultural heritage. The center was putting on display a Chinese mirrors that were 3,000 to 5,000 years old. And the curator wanted to give students the chance, visitors to the museum, the chance to have a visceral understanding of what these mirrors are. What do they feel like? What do they actually look like? And it's things that you can hold in your hand. So if you take one of those mirrors, and now in the modern world, you could begin to digitize it, you now have this digital record of that Chinese artifact. And as you know, once you have it digitally, you can put the tools to work and begin to manufacture it, first by testing it in wax, and then using the same composition of brass that was used 5,000 years ago in China to duplicate the mirror. And once you have the duplicated mirror, you can go ahead and duplicate copies of them. One of the goals of the exhibit is to show the effect of aging on this material. So the students didn't have 5,000 years in the semester, but what they're able to do is accelerate that aging process chemically. And so in the end, they had the track of a brand new mirror, a mirror that may be 500 years old, 1,000, 1,500, and being able to hold that mirror and passing around. So you can appreciate that the museum would not pass around a 5,000-year-old Chinese mirror, but thanks to the work of the students, you're able to feel it, you're able to look at it, and have a good understanding of what this technology actually is. Another group of students worked in the area of art and Michelangelo's David. And so in this work, what they're able to do is to look at the effects of strain and stress on David's ankles. So the sculpture is actually cracking at the ankles. You could think of it as the Achilles tendon, the weakest part. But what the team was able to do is actually design a tool to look at the strength of materials that were actually used to carve David, but also in other forms of sculpture. So this device that was created would load up materials to the point of failure, powered by an Arduino, manufactured, so you can understand the use of laser cutting. You can see the aluminum, the 80-20, the ability to create the models themselves, including David. So if you load up the bottom of David into the test mechanism, it actually goes ahead and compresses, and you can measure where that failure point actually is. So what this project is able to do is basically use engineering fundamentals and applying them to historic art so that people understand the difference between plaster of Paris, marble, and then actually concrete. This group of students that you're actually seeing, first-year students. So going from the high school actually to the being able to do sort of scientific work like this at the very first year. Senan, who had popped in there, is from Turkey. Michelle's a first alum from Texas. So some really, really great work. The video itself is online, and if you search for David's ankles, Yale, you actually can get a better explanation than what I just spoke over it. So in this concept of making, this is where I get to spend my time. During the day, it's a very nice and open area as students are perhaps sleeping, and it really comes alive at night when the students come into the space and make things happen. I think an important thing in our outreach at Yale is actually the experiences that have been provided by participating in the first program. These students are all first alums that participated in high school and also had the chance as college students to get involved in First Global. And would fondly remember the last time that Minal and I were together with some of you in Dubai. So that the world gathering to celebrate robotics, to celebrate science, to celebrate the impact. What we've been able to do is to take some Yale students on the left, Jamie, and then mentor students around the world, including this group in Vietnam. So this is Team Vietnam. We've also had students with Bangladesh. So Ian is a senior this year, mentoring Team Bangladesh remotely, and then coming together this now with Team Germany. The students were able to travel to Mexico City. We developed a special relationship with Team Afghanistan. Laura is one of our remote members. I just love this picture. And Minal, I'm sorry, this morning I tried to get the photo of us taken, but I couldn't find it in my in my photo bank. But just the world coming together to go ahead and to celebrate and to have fun and to motivate each other. I had mentioned Team Afghanistan. They're actually able to visit the United States and Canada and came to this Center for Engineering, Innovation, and Design. All the students that you see here are first alums, including the young women from Afghanistan, as well as the, I'll say the, American students that are there. Roya, who is the team leader there, is just a phenomenal figure. And what she has done is actually led a project to design a technical high school for young women in Afghanistan to give them opportunities in science and engineering that otherwise wouldn't be available. To help her out, we gathered a group of architects on our Yale campus, and they did the conceptual design for Roya's school, which was presented to the president of Afghanistan, President Ghani, who since deeded land at the University of Kabul. And so this Dreamer Institute is allowing Roya to give opportunities for education for young women and actually for young men in Afghanistan, using the same things that we're familiar with, providing access, providing opportunity and being surrounded with people that care and people that are actually motivated. So it's a wonderful, uplifting feeling of knowing that we here in New Haven can connect with Afghanistan and periodically meet in places such as Dubai to continue on that great work. And the Yale students are really the glue to make that all happen. We're going to take a peek at some students, and I want you to think that this is you in the next few years, because in fact, these individuals were just like you. They were in high school, they were on robotics team. Megan, when she came to campus, actually wanted to start a program launching rockets. And so she comes in and says, Dean Vince, I want to do a rocket program. I said, okay, Megan, as long as you, we're going to be safe and we're going to use these little rockets. Everyone's going to have safety goggles on, and perfect. So they go ahead and launch their rocket. The next, they did it on a weekend. When they come into Yale on Monday, Megan says, well, that was good as a practice, but we want to do some real rockets. And real rockets are a little bit bigger than the start. And so Megan began to lead this effort, which included getting the support of the Chief Executive Officer of Boeing, Jim McNerney, and there's Megan, to fuel her rocket project. And so her team grew, the size of the rockets grew, and where they launched them grew. In one project, the challenge was to take an egg and launch it into, quote, space. So as the rocket goes up, 5, 4, 3, 2, 1, blast off, it separates and the egg returns. And it's actually in a container to return to Earth. And the challenge is to take this egg and bring it up to space and bring it back down. So upon its arrival, it was aided by the fact that the team designed more than just a parachute, but what I call the eggocopter. So every element in this device that brought the egg back to Earth was designed by the students, manufactured by the students, and you can sort of see the helicopter design and the egg as it's being uncrated from its trip to space. If you watch Megan's face, you can see as they're uncrating it and evaluating the egg, and then we have success for its successful return to Earth without being broken. Megan herself, again, after taking this launch on, comes back and says, we really, really want to do big rockets. And so Megan, as a college student, is now inspiring others. To give you an idea of scale, the student on the ladder is David, and he is 2 meters. So we have some really, really big rockets, and they've been taken to areas within the United States that are very, very different than New Haven to go ahead and launch them. So what you're seeing is Megan, who's having an impact well beyond herself, but on others, including 2 students that spent the summer designing their own rocket testing system. And Glenn, who is on the left, ended up taking that experience and becoming a rocket engineer at SpaceX. And then Patrick, who is on the right, is at a small startup for a small satellite launch company called ABL Space Systems here in California. Without Megan's leadership, these 2 engineers would not be doing the work that they would be doing. I don't know what they would be doing, but I don't think that they would have had the experience in rocketry that got them some great trajectories as engineers. In addition to that, Megan drew in Carl Marbach. And so this is Carl carrying the rocket, as you can see, but this is what Carl normally does on Saturdays. And he's a player on the Yale football team. So Megan, who weighs in the neighborhood of maybe 120 pounds, and is maybe 5 feet tall, has influenced someone very, very different than herself. Someone that weighs twice as much, someone that's a foot taller, Carl Marbach. But it shows the impact of having an idea, making a team, and actually inspiring others. and then seeing the effect of that on their lives. And I think that's very, very important for the role that all of you are in. Alex Carrillo came to us from a first team in New York City. And when he came to campus, he worked on a project his first year for our museum of exploration that includes dinosaurs, but it also includes little carpenter ants. And so the exhibit needed to reduce the condensation in the carpenter ant habitat. So what Alex did was add an air conditioning system powered by an Arduino so that at the appropriate humidity conditions, the ants would be kept dry. Beyond that, he worked on a race car project. And this car is powered both by electricity and powered by internal combustion engine. And everything that was done on it, the design of it, the construction, the building, was taken care of by Yale students. And so it becomes very challenging to design a race car. And as the deputy dean, I have new responsibilities of keeping race car drivers safe as they go ahead and actually compete in something somewhat dangerous, but with the right precautions can actually be very, very safe and successful. And the team went on to win the competition. And Alex then went into other areas, working with our design center, wearing his first robotics shirt, sharing his knowledge with others, taking the bottom of a Segway and actually building a scientific instrument for measuring outdoor weather conditions, and then moving from cars and the land actually to the sea and building an autonomous sailboat. When Alex graduated, his next job was also with SpaceX, where he's a designer of the launch control systems. So here we see the example of someone doing everything that they can, making the most of their opportunities. And our last person to profile is Naoka Gangawardena. Naoka came to us as well from Girls of Steel robotics team. And along the way had a great experience as a robotics student, and then came to Yale and had even more experience. Part of her first year's project involved hippos and actually tracking hippos in Africa. So for that project, her work was actually deployed into the field to understand the migration of hippos. To do that, they built a device that the hippos would walk through and then get tagged so that the researchers could study them, doing all the work within the design center. At the end, that was her first year. At the end of her journey, she took on a project for medical technologies. And the work that she did was actually help surgeons that would do heart surgery. So rather than cut the sternum by hand, the team used the concepts of design and sketched out a solution to help the surgeons make a straight cut and then actually have that sternum begin to heal better. So you progress from your cartoon drawings, your simple sketches, to quickly using the tools that you have, whether that's paper or 3D printing or pipe cleaners, so that you get this understanding of the problem itself. Then you begin your prototyping phase with different material to actually see how it can work, including looking at the concept in this case of segmentation. If this is manufactured, how many links are needed to cover the majority of the human population? Once that is designed and you have your CAD drawings, you can actually then go into production. So there's over 60 components that were made by the students. And then once assembled, was this device that the cardiosurgeons could use to get a straighter cut and actually have that patient heal quicker. So the two things have happened. One is that there's a guide for the actual saw that is used, and then there are clasps that bring the sternum back together. So the change in technology goes from, on the right is the typical solution where wire is used to join the sternum together, and the student design is much tighter and much safer. As a little bit of demonstrating the creativity, they called themselves Team Thoracic part, which I thought was quite clever. Naoka now works for Dean Kamen. So she's doing the very work that she did as a college student that was influenced by her first trajectory as a professional. So what you're seeing here with Naoka and the others is actually their ability to not just think, plan, and do, but go ahead and create and to make a difference in their lives. Finishing up here, what does this all mean to you? You're in a similar environment now with the wonderful mentors that you have for Team India, with the wonderful mentors that you have on your first robotics teams. And even though we looked at these three students, what you have in common is, in fact, their ability to make a difference, their ability to make a team, their ability to make a most, and that concept of making, that concept of surrounding yourself with great people, in essence, is your special skill. So I'm really delighted to speak with you this morning and to give you some insights into people like yourselves that have had opportunity and have made the most of those opportunities. So with that, I invite some questions. And so, Anushi, I'm not sure if you want to take them into chat or have the students speak directly. And as far as the questions, there's a lot of topics we could speak about. One of them could be how this concept of making prepares you for a profession. I am very happy to talk about FIRST itself. As one of the board members of FIRST, we've been very active in responding to the pandemic and very active in planning of the pandemic. And we know that we've got a special season amongst us. Also very happy to talk about this concept of FIRST Global, of what we've been able to do under Dean Kamen's leadership of planting seeds throughout the world that instills entire nations with what has happened in India. That you can take this concept of giving students opportunities, surrounding them with wonderful mentors, and having the students learn, develop, and then spread that concept of inspiration, spread that concept of motivation through their local communities, their local provinces, and across an entire nation, as we've seen wonderfully done throughout India. So with that, it's just been a real pleasure to be able to speak with you, and I'm happy to spend the next 20 minutes or so taking on questions that folks may have.
Sorry, thank you. This was really a lovely talk, and so many insights actually. This was very inspirational. Can I ask the students to ask questions here, please?
Yes, please. So there is one, as they come in, there's one in the chat, and it says, how can I get admitted to Yale? And can I design things such as jetpacks like those in a James Bond movie? So how to get admitted to Yale? Doing exactly what you're doing now, and that's being connected within your community, but also giving very close attention to your studies so that you'll need top marks for the most competitive programs, but then also engagement beyond just your schoolwork into your broader community. And everyone on this call is able to do that through their first experience. So if you do get admitted and come to Yale, can you do a jetpack? Well, we did a race car, so we'd have to see whether or not we could do a jetpack. So delighted to take on the challenge. Okay, what is the daily working time at Yale University? So for one part of the university, it starts 9 o'clock in the morning and goes to say 5 o'clock at night. The student body themselves like to stay up a little bit later, and so that they would work a little bit later. But then in addition to what I focused on as the undergraduate curriculum, there's the researchers that are in the lab 24 hours. Now, not every person is in 24 hours, but in a lot of our work, the lab work continues around the clock. As you're doing experiments, as you're taking measurements, that there are students that are in there, you know, all the time. All right, this is great. And you know, if this works of just having questions come in by chat, we can do them. But I'd also welcome students to ask questions, you know, with voice and video, if that would work as well. So we can keep the chat ones here and we can get to them, but I invite students. So, all right, maybe we have our first one.
Yes, so yeah, so my question was, could you give some insight on how to balance the difference between the research that goes into coming up with the idea and the skill? So like I read about you being doing fellowships at the Charles Stark Draper Lab, and one of the most important things there is the balance between the applied research and the study that goes in. So I would like to know about that.
Sure, no, I think that that's a great question. You'd referred to working at the Massachusetts Institute of Technology, the Charles Stark Draper Lab, and that was really a highlight of my early career. The lab that I worked in did the automatic control system for the man landing on the moon. So it was a very historic lab to be working in there, and my work was on the automatic control of submarines. So as a submarine would move, how does it turn, but actually keep its yaw rate and pitch consistent? The question that you ask, I think, is an important one, and that's this sense of balance between cutting edge research and actually applications. So whether that's in the biomedical world, as we saw with Naoka, whether that's in research regarding coronavirus. So as example there, we have one of our researchers that is very experienced in microbes and is able to test the waste in sewage sludge to determine in real time what is the infection rate of an environment. So in that case, he's able to take his cutting edge research in the underlying science and immediately go ahead and apply that. As we've been in the pandemic and people have worked remotely, one of the fun projects that I was involved with was helping out our research team that uses animals as the model for their work. And in this particular case is that they created a turtle robot. So a robot that could walk on land, but then actually swim within the water. And so here too, you're seeing that you have that cutting edge awareness of what the science is, the biomechanics, but then the applications of putting it into practice with a turtle robot. So let me. You're welcome. Let me take a couple questions here because I feel bad if someone asked the question and I didn't get to it. So does Yale connect with institutes in Asia for workshops and student exchange? And they do. So there's any number of different connection points from the university into Asia and Africa on Yale experiences for international students. And we could, sort of come back to that or follow up with it afterwards. I didn't mention, but the project that we did with Afghanistan was actually supported by our International Affairs Office as an outreach program into Afghanistan. How impactful is first preparing students for a career in robotics? And that, I think, is it is just a wonderful, wonderful experience for you to increase your competitiveness for top positions at top companies. And why is that? Because not only do you know how to think and apply robotics and programming and software and electronics and interfaces, so systems integration, but most importantly as well, you know how to solve a big problem and work as a team. That is just not my answer, my answer, my answer. It's all of us working together. And if I can't do something, then I know that there's someone on my team that can help me. And if there's ways that I can contribute to them, that benefits them as a person. So this whole aspect of FIRST Robotics as a way of developing all of your skills, your technical skills, your teamwork skills, your communication skills, is just ideal for both your trajectory in universities or your trajectory as a career in robotics or programming or any number of dimensions, even I would say some non-engineering, non-scientific dimensions. Which subjects do you look for while admitting students for undergraduate level, and what is the admission rate? The admission rate at Yale and Stanford and similar very competitive universities is 6%, 5%, depending on the year. Now, I know that's very small percentage, but my point to all of you is that these universities want the very best students. So to look at universities that are competitive, I think is a good goal to have. And whether there are universities in India, whether there are universities in the UK, whether there are universities in China, whether there are universities in the United States, is that very small proportion comes from students around the world. So to take your work and to focus it, I think is a very, very good thing to do. The question also asks, what does the university look for in admitting students at the undergraduate level? And that's very, very easy for me to describe, is they look for three things, okay? And so I'm doing a little bit of a why. In this way, they're looking for depth within your discipline, depth within your engineering, depth within your science. In this direction, they're looking, Yale is looking for not just science and engineering, but your interest in social studies and the humanities, the origins of art, the history of the world, literature, languages. That's the social studies and humanities dimension. And where this works out for us is this third component is people that are able to take that experience in their discipline, their liberal arts experience, and make a difference in the world, to take on problems of purpose. And so those three dimensions, your breadth, your depth, and then your trajectory, your problems of purpose, are really what Yale College is looking for undergraduate students. How has COVID disrupted Yale's work in engineering, and how have they adapted? One of the interesting aspects of working on FIRST Global this year has actually been to see the work across the world. And the pandemic has actually united us in purpose and united us in our response. So it's very, very interesting as we put out this year's challenge of various projects and engineering challenges to teams around the world, to see them respond, but to see that everyone was doing it under the same limiting conditions of the pandemic. So keeping distance away, always wearing masks, being very careful on interacting. And so similarly, that was the same thing at the university. For the class that I teach during the fall, we did our lecture instruction online like this, but we did our in-person labs in a very different way. So if we had an in-person lab that previously would be a team-based project, we had to take that project, divide it into separate components so that each student could work individually and then pass one part to another to another. Some of the way things actually worked out quite well. So if you're doing computer coding and someone has a question, normally you would stick your head way into their computer and begin to look at their screen. But now 3 or 4 people could look at that same code using Zoom. If we needed to do a close-up of a physical device, say this little bulldog here, this year we've all got the opportunity of bringing those devices up close. So having technology actually work for us. So it has been a challenge, but I'm very, very, proud of the work that the students did. The work that they were able to do in our product development class is as good as any other time. So really, really, just super proud of them being able to accomplish things during the very challenging conditions. Can I start research in my first year? Absolutely. So I know during my talk, we spent a lot of time on application side, but hand in hand with that is working in faculty labs doing the fundamental research. I had mentioned the turtle robot, that's Professor Kramer. She takes in a number of first students into her robotics lab each year, and you can appreciate that. Professor Madhu Van Kandasen, as well, takes in a number of students that are proficient in computing, in robotics, and he does human walking studies. So there's plenty of room for research for students to be involved in, including the first year on campus. Okay, I'll pause and see who might have questions. There's a lot in the chat, so I want to make sure I can get to those too. Go ahead, Taral. Or anyone. Okay, I'll keep going. I'm in grade 8. You've really inspired me with your slides and what you shared. My question, how can I plan on getting admitted to Yale over the next few years? You're doing the right thing. You're on your first team, you're working with others, you're spending your time productively. When you're doing a project such as the heart surgery device, how does someone know that the project is ready to go to the next stage? That's very, very good. I didn't tell the whole story, but the whole story for that project involved working with the surgeons themselves. So getting the input from the surgeons on, here's what we're planning to do. The project actually originated from the operating room. And so Naoka and her teammates had direct access to the surgeons. And just like your robot, I mean, it starts as a sketch and then it goes into each mechanism that you would try very quickly, maybe using cardboard to understand how something could work, or some available metal or wood that you could then laser cut or machine. And you're doing this incremental process from the original design to a prototype to an advanced prototype to the final thing. The same with these commercial devices, that for the cardiac surgery device, there were many, many iterations. And I think the important part is that the team itself is gaining an awareness, and so they can walk the product through this own journey with the help of the faculty leads and with the help of the surgeons. How do teams of researchers evaluate the possible impact that their work may or may not have on society and the world? That comes about by doing things like this, by having conferences and discussions with colleagues around the world. The traditional form of sharing information is in written journals, so that you see the exact work, you see the data sets, you actually see the results. So by conferring with others, pre-COVID, a lot of that was done in person, but I think all of us now have increased our comfort sharing information in this format. As a sort of an interesting story, in 2003, myself and a colleague actually did a first robotics team in a distributed manner. So Zoom didn't exist. There were some internet technologies that were actually put together, and we designed and fabricated a first robot in 2003. So it's almost 20 years ago, using the same technologies. And then we got together we're in Connecticut, but students were from around the United States, and then got together in California. So it was really sort of an exciting aspect of seeing what distributed teams can actually do. Will robotics count as an extracurricular activity if your team reaches the international level? Yes, but it also counts as an extracurricular activity if you do not reach the international level. So within Yale and many institutions in the United States, the FIRST Robotics program is well recognized for what it does. And so being on a team and being a team leader and doing work that your mentors can reference and note in their supporting documents is very, very important. Coming from Fairfield County, Connecticut here, do you guys advocate for using multiple aspects in engineering, artificial intelligence in engineering, and how do you foster these relationships? So greetings within our state. So Fairfield County is, not too far away. With the topics of artificial intelligence, in engineering, just like COVID has broken down the barriers for collaboration, I think the aspects such as artificial intelligence is in the same realm. In that is that the concept of artificial intelligence can be applied for improving our communications, for improving the diagnosis of healthcare, for improving design itself. Now, how does that happen? The same way it happens on your first team is that you get people of different backgrounds and you've got a big problem to solve. And then you apply that information from different backgrounds, such as the concept of artificial intelligence. Is Yale planning on launching an undergraduate program in robotics? That does exist at some US universities. Right now, no. Relying on our traditional majors of mechanical engineering, electrical, biomedical, environmental, chemical, applied physics, and then computer science begin to serve us well. But I wouldn't be worried about a major in a specific discipline. I think I would concentrate on making an impact within your time as a high school student, within your time as a college student, and then having artifacts that can help you be competitive for graduate school, that can help you be competitive for jobs in industry. So it's less important of what your degree is and more important on what you actually can do. Does Yale give credit for academics or extracurriculars during the process of accepting students? Absolutely. They pay great attention to that. And I think one of the things that allows us to rely on this depth, breadth, and problems of purpose is in fact the attention that all of the learning is not in the classroom, that your mark of potential is not limited to your grades, to your marks themselves, but rather what you have done as an indication of what you can do. On internships or summer programs available to international high school students, Yale itself does have programs called the Global Scholar. Within our area of engineering design, we do not have international programs because we're very active with the Yale students, which includes international Yale students, but not for students that are not in the university.
Can I ask this question? So my question is that how much has the science fiction genre possibly inspired us high school graduates who seek to adapt such technology from the real to the real life? I mean, science fiction has always constituted a huge percentage of our own childhood. So how much has it inspired us to adapt such technology?
Yeah, it's wonderful. So thank you for that. As Dean Kamen says, the only difference between science fiction and science is actually time. So many areas that were science fiction are now science. So Jules Verne, it could start with Around the World, 180 days. Unbelievable that you could do that in nonstop on a jet airplane. The Journey to the Center of the Earth, as Elon Musk now has a boring machine, things like that become possible. If you look at flight itself, which started in 1903, and by 1969, we've gone from nothing, no human has really ever left the Earth in a propelled device, noting that there's balloons, but then landing 250,000 miles away in the moon. And now us thinking about inhabiting Mars. So I think science fiction is a wonderful motivator, and it gets back to this creativity aspect and this ability to, yes, have science and engineering is key, but then getting the ideas from other areas, such as nature, such as literature, and where those applications can be made is very, very important. So, other questions? So we got a question on a tech startup in Hong Kong. I'm keen to connect Cyberport with you and your team at first. Can I have your coordinates and email? And for that person, and that's Kamal Shah, if you want to connect with me now afterwards, I'm happy to chat with you. We didn't speak at all about entrepreneurship and innovation explicitly, but that's a very, very big component of Yale University, and even more so right now. So I spoke a lot about the lab that I work in, the Center for Engineering, Innovation, and Design. Right next to us, there's an accompanying facility that's brand new that allows students to take any innovations that they can think of and put them into practice. And that might be on curing homelessness, solving problems with hunger, or developing commercial products. So right now, we're in the midst of working together to actually take some of our student projects and convert them into commercial products that you could go and purchase work that students have created in the classroom. Our model for doing that is to do it under the university umbrella, that we could charge a fee for the services, and you could buy these products. And that allows us to do it as an educational activity, so that as opposed to starting a company, which this is training for the students to do that at any level of that development, you can call this a success. So for example, right now we have a project on measuring an exercise, a squat exercise that has been we've worked with our Department of Athletics. We've taken that student project and we've advanced it to the point where the next step is to mass produce it. So you would make the injection molding, you would print the circuit boards, and we're now evaluating the internally designed and manufactured units, that we have 50 of them, to see if it has potential to move to that next step as an actual product. And so that's a big focus of Yale University and the School of Engineering, is to ease that idea actually into entrepreneurship, that idea into a commercial product pipeline. Is Yale more appreciative of candidates who are hyper-focused on a limited set of activities, or those who dabble in many things? I think the answer is that you just as we look for people that have breadth, depth, and problems of purpose, rather than dabbling, if you take that interest and that dabbling and you're actually doing something with it so that you have concrete performance in some of your areas of dabble, will serve your application very, very well. And I think I'm at the end of the chat question, so I'm really super excited if there's other questions that people have, because I didn't want anyone not to be able to get an answer in their chat, but happy to take other questions from the team here. So,
Sir?
Any questions? Yeah, hi.
So I have a question. Sir, can you hear me?
yes, I can.
Yes, sir. So, sir, I have a question. So, sir, what weighs more? Do your marks weigh more? Or does like extracurricular activities like doing robotics and other activities weigh more?
So I think it's fair to say that everything weighs more. And I know that doesn't help you, but you definitely need very strong marks. And then you also need very strong performance within your extracurriculars. And if you go back to the previous question, rather than have 20 extracurricular activities that you do a little bit in, I think you're in a great position of doing a lot within your first team. And so you've shown great progress and great impact with the extracurricular activity of FIRST Robotics. And that may extend into any number of different elements, as I had said on the making side. But that has to come hand in hand with high marks. So the ability to perform at a top level as measured by testing is important, but also your impact within the world. So,
and so what are the average marks?
What's that?
What are the average marks that you have to get in your board exams?
So within the SAT marks, we're talking 750 and above. So, pretty competitive. So there was a question here. May I get to know what the first is? And
I have a question.
Okay, did someone want to ask that or no? So the question says, may I get to know what the first is? So FIRST is our group that stands for Inspiration and Recognition of Science and Technology. And that group poses technical challenges to students around the world, and they come together in their school environment, in their community environment. They build solutions to those technical challenges, and then come together as a community, both in a region, both in a nation, both in a global state, and celebrate that science and technology. So if you search FIRST, it's actually the first thing that'll pop up in your Google window. A couple other questions. I see Yale as the confluence of arts and engineering. Does studying the humanities help engineering students be more creative? I think absolutely. And in the midst of that community, you're surrounded by creative individuals. So you are creative in yourself, and your creativity may be along the engineering and the science side, but being exposed to people that are creative in music, that are creative in art, will add to your own creativity, and then your sense of science creativity adds to theirs. How is the research funded? In any number of different ways, in that the government can supply research funding, organizations such as businesses or groups, say like FIRST, if they needed a problem solved, could actually provide funding for that research. An athlete, talking about the recruiting process or a simple application, at these most competitive schools, the athlete is, again, it's just one component of their application. So where we're talking about success in robotics, that dimension for the athlete is their success within athletics. So if you're a FIRST robotics student that also is a top athlete, that's a very commendable, and then that success will be noted in many different areas. Is your research limited to your major or your field of study? Or are you allowed to explore new ways of solving problems? So the concept of research is joining a research team. The leaders of that team really are less concerned about your major and more concerned about what you can do. And so if you can code, it doesn't matter if you're an English major. If you can machine, it doesn't matter that you study languages. It's actually your contribution to the lab facility. Mostly people are going to be within that background, but that doesn't have to be itself. How can I get involved with FIRST activities and challenges? Should I inquire with my school? Are there other requirements as well? And I think Manal can help you of, oh my gosh, there's this thing called FIRST. What can I do? So reach back to your school. Please, you can reach to me if you want to find me. If you type into the internet, Yale Engineering Vince, there's only one. And so you can send me a note and we can see what we can do to connect you with the resources within your area. How could a student conduct their own research in the field of STEM with limited research possibilities? I think in the concept of research, we often look at the very big research that is out there. And it typically, and I'm sorry to say this, that the student research initiatives don't get as much attention, but at the same time, you've got the opportunity to work with individuals that are Nobel Prize winners, that are the best researchers in the world. And so viewing that as an opportunity to learn about their discipline, to learn about research methods is very, very valuable. And then as you progress within your career, to have that chance to go ahead and initiate your own research. Okay, I think I cleared the chat again.
Great. I think we are, any more questions?
I have one.
Okay.
Sure.
Yeah. So I thought the minimum SAT score you needed was around 790, 795 to get in.
Yeah, so I think it's not the minimum, but we're given a range. So they online, you can actually see the percentage of students at each of the score levels and that were admitted. And like anything, the higher marks, you're going to become more competitive. But it is not uncommon to have students at, like I had mentioned, the 750 range if they have exemplary success in other dimensions.
Other dimensions include, can you give some examples?
Yes, so it could include the engagement within your community, your contributions to a FIRST robotics program, your own independent research that would be presented at science fairs, or it is not uncommon for students to have published in scientific journals. I think the whole concept of sharing your work broadly. So if you are active in a number of different areas, to assemble a digital portfolio that would be then a component of your application. So that in addition to answering the standard questions, there's a list of your work as it relates to a student applying to a university, where you could capture snippets of all the activities that you've done, that you've participated in.
So I have a question, like, what does your own research entail? Like,
sure. So my research right now, if you will, is on this concept of design and product development.
I've been referring to, like you said, when you applying your own research, your research is important. What does a student's research entail?
I see. So I said it could be important if you do have a research portfolio, and that could be pursuing any topic that was interest you, or it just doesn't have to be research. It could be impact that was made by you creating things. It could be impact by you teaching within your community. For those not in science and engineering, it could be your impact as a performer. So that's the many areas of your personal development that also can be evaluated.
Can you give an example of some kind of scientific research or engineering research a student has done?
Yes, so I won't have the details off the top of my head, but we had a student that was very, very active in environmental engineering and in processing water. So converting seawater to fresh water. And that's a pretty, quote, scientific area. It's, not something that many students have access to do, of how to build the thermal systems, how to build the testing systems. But that student was exceptional. And just like you, they were surrounded by mentors, both within the community and within their school system, that guided that research of a desalinization system.
Okay. Thank you.
Great.
You're welcome.
Thank you. I think are there any more questions in the chat? We've done them, right?
Yeah, actually, I was pausing. So we got visitors from Singapore. So wonderful to hear that. We actually have the National University of Singapore and Yale have an affiliation. So that's really great. How can I get involved with FIRST activities and challenges? Again, if you send me a note, we can find the resources in Singapore. We have FIRST teams in Singapore. We can connect you with that.
We have two FIRST teams now in Singapore. We have two FRC teams.
Okay.
So we have one in the United World College Singapore, and which again I started and I'm mentoring this year. That's a rookie team. And we have one at the National Public School Singapore, and we have students from there here as well. And a third team is likely to start early next year. So
that's wonderful.
First,
so plenty
FRC
of opportunities.
Yeah, absolutely. FRC is really becoming popular there. Kids are enjoying the experience. In fact, one team has already built a robot, which is quite amazing, and we look forward to showcasing that.
So there are a couple questions. I can do them real quick. Can Yale help a person be a United Nations-based humanitarian career? Absolutely. Does it have subjects like global affairs and international policy? Absolutely. And these are very, very prestigious programs with tremendous success. So it is not uncommon for U.S. ambassadors, for U.S. Secretary of State to have studied this very area at Yale. Is participation in FIRST activities recognized by other universities as well? Absolutely. And so Dean Kamen has been very, very active in getting other universities to understand the value of FIRST. And no matter where you're applying, I think it's important for you to capture the work that you've done within your robotics team. Wow, we're up to 70 participants from around the world. That's just, usually this doesn't happen to me on a Saturday morning.
When we started, we were 90. I think people just dropped off a little bit later, but there has been a lot of excitement for your talk. And I've had lots of questions saying, can we ask these questions? And I said, of course, be open and ask all the questions that you have for you. But yes, this has been extremely impactful, I think, and inspiring for the students. I can see a lot of Yale, people wanting to apply to Yale, and also from the FIRST perspective, getting to know more about how FIRST is valued by colleges and corporates, organizations. So this will definitely have an impact on students to know that their first robotics experience is really something big.
That's perfect.
Thank you so much for your time today.
You are welcome, and I wish everybody well. And we're really looking forward to 2021, where we can take on many, many different activities that have been suspended over this year. Be well, everyone, and thank you so much for the chance to talk.
Thank you so much for your time. I do have a student who wanted to kind of say a vote of thanks. Shiv, are you there?
Yeah.
Thank you so much, Dean Vince, for such an insightful talk. As a student, a programmer, and a STEAM enthusiast, I really enjoyed your introduction to the Center for Engineering, Innovation, and Design. I think all of the projects that you spoke about, from testing statues to rockets to race cars, they're all extremely interesting and really inspiring. Thank you so much for your time.
Shiv, you and your partners are all welcome. Very happy to do this. Have a grand day. Bye-bye.
Bye.
Sir?